day, everyone. Today we are having chemistry, and the subject of today's class, or the title of today's class, is Ionic theory, which will be linked with electrolysis. So, what are the objectives of this session? The students must be able to differentiate metals from non-metals. They must understand the factors that govern the selective discharge of ions. They must understand the following terms: electrolysis, electrolyte, non-electrolyte, electrodes, anode, cathode. They must be able to construct the diagram of a simple electrolytic cell, offhand, and lots more. So now let's begin. Okay, start with okay let's start with the let's start with this. So we have a man who is known as Arrhenius. Arrhenius was the first man who presented the Ionic theory in 1886. Let me come again. Arrhenius was the first man who presented the Ionic theory in 1887 to explain the phenomenon of electrolysis. Was the first man who presented the Ionic theory in 1887 to explain the phenomenon of electrolysis. The theory pointed out that when an electrolyte is dissolved in water or melted, some or all the electrolytes dissociate or break up into freely moving charged particles called ions. We'll see explain these terms that are used here. So the theory pointed out that when an electrolyte is dissolved in water or melted, some or all the electrolytes dissociate or break up into freely moving charged particles called ions, and the process of dissociation into ions is known as ionization. So this is an illustration of what has been stated here. Don't worry about that, the terms will be explained soon, very soon. So it is stated that when an electrolyte, here is the electrolyte, when an electrolyte is dissolved in water, so in the process of electrolysis, which we will soon get to, when the electrolyte, here is the electrolyte, is dissolved in water, that means when it reacts with water, that's when it dissolves in water, what happens? Some or all the electrolytes dissociate. What happens? The electrolytes will dissociate into ions. Some or all the electrolytes will dissociate or break up into freely moving charged particles called ions. So note that freely moving charged particles called ions, and these are ions. And the process of dissociation into ions is known as ionization. So the process of the electrolytes dissociating into ions is known as ionization. Now, let's look at what the definition of the word ionization. Ionization can also be defined as the process of electron loss by the metals. So we've received the first definition here, which is the dissociation of the electrolyte, this compound, in aqueous solution, AQ, into ions, freely moving charged particles. So what do we have here now? We have that ionization can also be defined as the process of electron loss by the metals. It implies that when a metal loses an electron, we can also refer the term as an ionization process. When a metal loses an electron or loses electron, it could also be an ionization process. For example, this is the sodium element. Can you see? This is the sodium atom here. It loses an electron, then becomes an ion here. And magnesium as well, losing 2 electrons and becoming an ion. So that's known as ionization. When a metal, I can also be defined as process of electron loss by the metals, which implies that sodium is a metal while magnesium atom here is a metal. What's an ion? We have here an ion is a charged atom. So these ions we have been referring to, they are what? An ion is a charged atom or a group of atoms. So an ion is a charged atom or a group of atoms An ion is a charged atom or a group of atoms. So in brackets you can see there's a word in bracket there written as radical. It implies that the group of atoms that is stated in this statement is radical. So let's come again. An ion is a charged atom or a group of atoms So what it implies that these atoms that are shown here, they are different from these ones here, because these ones are not charged while these ones are charged. And when we see charged atoms, they are known as ions. That's when a charged atom, an ion is when an atom has either gained or lose electrons. So when we see atoms are already charged, they are known as ions. But when they are not in groups, that's when they are known as radical, which is a radical is a charged group of atoms. It's a charged group of atoms. An example, we have this. Can you see? This is slightly different from this, because SO4, sodium tetrahydrosulfate 6. We have hydrogen tetrahydrosulfate 6. We have NH4. We have the ammonium. We have a lot of them. So these ones are known as radicals because they are charged group of atoms. They are group of atoms. It doesn't contain a single atom. It's a compound. It's a radical. So now let's proceed to what's next. So we have what is known as metallic ion. We have what is known as a metallic ion, and also known as what is also known as a non-metallic ion, because we said, move back a little bit, we said an ion is a charged atom or a group of atoms. So what do we refer to as metallic ion? Because when we begin to work under electrolysis, we'll be working with the metallic ions and non-metallic ions. So we need to understand these basic terms. So a metallic ion is formed by the corresponding atom by the loss of electrons equivalent to its valency. What does it mean? It means that a metallic ion is formed when a metal atom loses electrons. It is formed when a metal atom loses electrons. So this is an example of a metal atom. Calcium is an example of a metal atom, and it loses 2 electrons here, which is what's positively charged. So that is an example of a metallic ion. See calcium, can see A2 plus here, and potassium here as well loses an electron, which makes it positively charged. So what we refer to as non-metallic ion. The non-metallic ion is formed from the corresponding atom by the gain of a number of electrons equal to the valency of the atom. So here as well, chlorine here loses chlorine here gains electron. There's a difference between these two signs. Can you see? Chlorine atom gains electrons to become negatively charged, which is a non-metallic atom. So we should and oxygen here as well gains 2 electrons. So we should know that metallic ions loses electrons while non-metallic ions gain electrons. So some common terms used in the study of electrolysis. Looking at these common terms, we have electrolysis, electrolytes, non-electrolytes, electrodes, anode, and cathode. So what do we mean when we state the word electrolysis? Electrolysis is the chemical decomposition of a compound by the passage of electric current through a molten or solution of the compound. So better explanations will be done very soon in this video. So electrolysis is the chemical decomposition of a compound by the passage of electric current through a molten or solution of the compound. What it implies that electric current here is passed through a molten or solution of the compound. Is passed through the solution of that compound. Is passed through a compound, which makes the compound. It is passed through the solution of the compound, which makes the compound decomposes. So electrolytes here, and the process of the decomposition. So As I've said, electrolysis is the decomposition of a compound by the passage of electric current through a molten or solution of the compound. So electrolytes, which implies that the process of the chemical decomposition of a compound by the passage of electric current through the solution is known as of the compound is known as electrolysis. While electrolyte is a compound in molten or in solution form. So we stated that an electric current will pass through a molten or solution of a compound. So the solution of the compound that is being referred here is the electrolyte, which implies that we pass the electric current is passed through the electrolyte, and which makes the compound decompose. So which also implies that the electrolytes are compounds. Okay, so electrolyte is a compound in molten or in solution form which can conduct electricity and is decomposed by the electric current. So it's decomposed by the electric current. When the electric current passes through the electrolyte, when it passes through the solution compound in molten or in solution form, it decomposes. The electric current makes it decompose. And examples of electrolytes are salt, the alkalis, and acids. We have a lot of electrolytes. So what is stated here, concentrated hydrogen tetraoxide 6 is not an electrolyte. So when we have the hydrogen tetraoxide acid concentrated, which is free from water, it is not an electrolyte. Why? Because it is already a concentrated acid. But when it is in a diluted form, then it is an electrolyte. It is an electrolyte in its diluted form. That's something we should note. So what are non-electrolytes? What do we refer to as non-electrolyte? A non-electrolyte is a compound which cannot conduct electricity in solution or in molten form. So we should also know that electrolytes conduct electricity in molten or in solution form. But while non-electrolytes are compounds which cannot conduct electricity in solution or in molten form, it cannot allow electricity to pass through it. It cannot therefore be decomposed by electric currents, which implies that when the electric current here passes through the compound, passes through the solution of the compound, it cannot be decomposed by the electric current. They are also what covalent compounds, and they contain no ions. They are covalent compounds and they contain no ions. So examples are ester. You have the examples are ether, benzene, etc. Electrolytes here as well, because these are the terms we'll be using when we are treating how the electric current is passed through the molten or solution of the compound, which is known as electrolysis. So electrolytes are the two poles of carbon or metal at which electric current enters or leaves the electrolyte. So they are like the terminal by which electric current enters the compound. The electric current reaches the compound. It's like a passage. So electrodes are like passages. They are like the terminals. They are the two poles of carbon or metal at which the electric current enters or leaves the electrolyte. So we get to see the diagram now. And anode is the positive, and why anode is the positive electrode through which the electrons leave the electrolyte, and cathode is the negative electrode through which electrons enter the electrolyte. So we'll get to see that now. So yes, this is an example of an electrolytic cell. So let's make use of this an example. Now, what do we have here? We have electrolytes. Okay, let's begin with electrolysis. So now let's compare. Let's perform a comparison. Electrolysis is the chemical decomposition of a compound by the passage of electric current through a molten or solution of the compound. When the electric current, so it implies that electric current is passed through what? Is passed into this electrolyte here. It's passed into the electrolyte here, and we talked about the electrodes. We said they are the two poles of carbon or metal at which electric current enters or leaves the electrolyte. So these are the terminals. These are the two poles. These are the electrodes, which are the anode and cathode electrodes. And we should note here that the anode is the positive electrode. It is a positive electrode. Can you see it here? Is the positive electrode here, sorry, through which the electrons leave the electrolyte. Through which electrons leave the electrolyte. It means electrons leave the electrolyte through the anode, and while the cathode is negative electrode through which the electrons enter the electrolyte. Is a negative electrode through which electrons enter the electrolyte. So we have this here, the same illustration. So now, what do we refer to as example? I know we have explained ionization. So what are examples of ionization? As we said, ionization is the chemical decomposition of compounds. Is the chemical decomposition of electrolytes. Is the chemical decomposition of metals, which is stated here. Ionization is what? Okay, this is the process of dissociation into ions. The process of dissociation into ions is known as ionization. When these electrolytes, these compounds dissociate into ions. So the examples of ionization here, compounds and ions, we have discharge acid. Can you see how it's dissociated? We should note this into ions. Okay, perhaps I should illustrate that here. We have tetraoxosulfuric acid. We have H2 SO4 hydrogen tetrasulfuric acid. What happens? It dissociates into ions. So it dissociates into ions by what? Having two atoms of hydrogen here, 2H plus, then tetraoxosulfuric acid here, SO4 2 minus. Can you see it now? It contains two atoms of hydrogen and tetraoxosulfuric acid here. So this is how this acid decomposes to give what? To give this. The acid decomposes to give that. So now, what we should note here is that, okay, let's proceed with the explanation. So now let's move to another one. Here we have the sodium chloride. As we all know how the compound is written, because you are expected to have understood this. NaCl. I think the handwriting is getting bigger. Let me make it smaller. The sodium chloride NaCl decomposes to form Na plus and Cl minus here. Can you all see it? Na plus and Cl minus. So sodium hydro, we have the sodium hydroxide as well here. So you should also know that how they are able to how these compounds are able to decompose will make us determine that they are electrolytes, because we stated earlier that non-electrolytes do not decompose to form ions. They do not contain ions. They are covalent compounds, but these electrolytes are not covalent. These electrolytes decompose to form ions. So now let's proceed. So okay, before we proceed, I think, okay, we have this here. We went to more. Okay, sorry. Now, before we proceed now, we are now getting into the process of electrolysis, because we stated that the electrolysis is the process of chemical decomposition of ions. The process of chemical decomposition of a compound by the passage of electric current through a molten or solution of the compound. So when the electric current passes through the electrolyte, it passes through the electrolyte and decomposes it. It decomposes the compound, because the electrolytes are the compounds. So we will now be getting fully into the process of electrolysis. So now, In the process of electrolysis, we stated that the anode is the terminal that allows the electric current to enter the electrolyte, as it has been stated here. Anode is the positive electrolyte. Anode rather. Anode is the positive electrode through which the electrons leave the electrolyte. Through which the electrons leave the electrolyte. The electrons leave the electrolyte through the anode and enters the electrolyte through the cathode. You should note that as well. So now, that's what happens in the process of electrolysis, because the process starts from here. That's where the electrolyte is contained in its molten or in solution of a compound. So in this process of electrolytes, we said this compound reacts with water. It dissolves with water. If you can remember, as has been stated here, it's the chemical conversion of a compound by the passage of electric current through a molten or solution of the compound. So that shows that the substance would have reacted with water, and when the substance reacts with water, for example, we have this here. When we have H2SO4, the tetraoxosulfuric acid, and we have H2O, water. When these two is formed, that gives the what? When these two react, when they react, that's when we can obtain the aqueous solution of this. So in the process of electrolysis, we'll be considering an electrolyte and water. We'll be considering an electrolyte and water. What do I mean? Now, we have the electrolytes in electrolysis, as we stated, are compounds that are in their molten forms. They are compounds that can decompose, that can form ions. So when we are working with electrolysis, when the ions are getting ready to be transferred through the electrodes, we'll be considering two electrolytes. What are the electrolytes? Will be water and what? Any other electrolyte. The electrolyte will be what? Water and any other one. The compounds will be water and any other one. So now, what do we mean by that? So now, let's look at this slide here. We have the selective discharge of ions. We have the selective discharge of ions here. Now, let's read this. When two or more ions of similar charge are present in a solution, when two or more ions of similar charge are present in a solution under similar conditions, one is selected for discharge at each of the electrodes. Again, when two or more ions of similar charge are present in a solution under similar conditions. So let's proceed. So, selective discharge of ions. When two or more ions of similar charge are present in a solution under similar conditions, one is selected for discharge at each of the electrodes. The preferential selection is dependent on the following factors. So now, let's give an explanation of that. Okay, let me open the board. Let me raise this up. Like I said earlier, when we are considering the compounds that would be when we are considering the compounds in electrolysis, we have to consider water and the other compound. So let's assume we are working with sodium chloride. Yes, sodium chloride. Let's assume sodium chloride. When we assume sodium chloride is in the aqueous solution, when we assume sodium chloride is in its aqueous solution, it means it's reacted with water. Water is contained in it. That shows that what? And how can this be felt? How can it be decomposed? As we told you, electrolytes are those ones that contain ions. We write Na plus, like I said earlier, plus what? Cl minus. which implies that the electrolytes will be what? Will be decomposed by the electric current to make them form ions. And by that, and we learnt that the electrode, which is the cathode, allows electric current to enter the electrolyte. So now, and I said we'll be considering water as well. So let's just, okay, we should not do that. So now we'll be considering water here, which is H2O. When H2O decomposes, we get what do we have? We have O. Okay, we have H plus and OH minus. We have H plus and OH minus, which is what we are going to obtain, the hydroxide ion and the hydrogen ion. Here we have, which is also the sodium ion and chlorine ion here as well. So now what are we going to do? How does this relate with this now? So let's now look at how does this relate with this. So when these two compounds are contained in the container, so when they are formed, they become the electrolytes, and the electric current enter the cathode, enter the electrolytes through the cathode in order to decompose these ones that are here, in order to decompose them to form these ions. Now in electrolysis, we have ions that are selected for provincial discharge, which is stated here. That means ions that are selected to move up, ions that are selected to pass through these terminals. We have the ions that are selected to do that. We have numbers of selected ions that are required to do that, to pass through this terminal to carry out the process of electrolysis. So that's what we are looking at in this segment of the lecture. So how do we select those charges? How do we select those ions? What are the selective discharge? What are the factors that govern the selective discharge of ions? How do we determine the ions that will be discharged to undergo that process? How do we determine the ions that will be discharged, that will be released to pass through the terminals? How do we determine them? So that's what we are looking at now. So when two or more ions of similar charge are present in a solution, so this is it here, and we have these two in the solution already now, sodium chloride and water in the solution, and this here is positively charged, while this is positively charged. So that's what it's saying, that when two or more ions of similar charge are present in a solution under similar conditions, one is selected for discharge at each of the electrodes. The provincial selection is dependent on the following factors. So the ways we can determine the ions that will be discharged are based on some factors. So what are the factors? Firstly, the position of the ions in the electrochemical series. Now, what it implies that the ion that will be selected for the provincial discharge can be based on the position of the position of that ion in the electrochemical series. So now let's look at that. Now the ion, let's give this test over here. The ions lower in the electrochemical series will be discharged in preference to the ion higher up in the electrochemical series if all factors are constant. Firstly, we should all know that this is how the electrochemical series is arranged, and this is how it should be known. This is how you should understand it. It starts with the potassium. These ones are positively charged and negatively charged, the anions and the cations. You have potassium ion here sodium ion, magnesium ion, zinc ion, we have iron ion, we have lead ion, we have hydrogen ion, we have copper ion, and um, we have which is the silver, and we have the cat ions here, and we have the anions here. So the electrochemical series is also known as the activity series of elements. It is also known as the activity series of elements. So let's take that again: the potassium, the sodium ion, magnesium ion, zinc, the iron, the lead, the hydrogen ion, copper ion, and the silver ion. And why this we have etc. So we have various acids here. We have a lot of them here. So now the ions, now let's look at how the ions are selected based on the position in the based on its position in the electrochemical series. Now the ions lower in the electrochemical series ECS will be discharged in preference to the ion higher up in the electrochemical series if all factors are constant. Thus, in sodium tetraoxide solution containing H plus from H2 and sodium, H plus is discharged in preference to sodium because it is lower in the electrochemical series and will require less energy for it to be discharged. The ions present are these. OA will be the potential discharge because of the same reason. So now let's take a practical example of that. So what are the electrolytes involved, the compounds involved? Okay, we have Na2SO4. So let's use that here. Okay, I think we have to erase this. We can also use that, but okay, so that they can be compared. So Na2 SO4, we have this here. So what's stated here? Thus, in Na2SO4 solution containing H plus from H2O and that, so in its solution state, it will have contained H2O. And looking at this, when this decomposes, we get what? We get 2 Na plus and what? SO4 2 minus. You should note that, please. It's very important. Oh, sorry, there's a mistake here. I'm very sorry of that. So let me erase this. That was actually a mistake. So we have this decomposes here because when we decide to form this back to this form, this switch transfer to this part, so which forms Na2SO4. So now the composition of Na2SO4 gives this. Why for hydrogen, why for water, H2O gives the hydrogen ion plus the hydroxide ion. So gives the hydrogen ion plus hydroxide ion. You notice that there are positive and negative ions here. So what do we have here? We have, thus in Na2SO4 solution containing H plus from H2 and H plus is discharged in preference to Na plus. So what it means is that, what is implies, what it indicates is that the ions lower in the electrochemical series will be discharged in preference to the ion higher up in the electrochemical series if all factors are constant. So when we look at this electrochemical series and we look at these equations here, in order to determine because in electrochemical series we find out that this set of one of them is transferred to the electrode for the first electrode, and the other one is transferred to the other electrodes. So we will get to know about that, because when we look at this here we find out that it is the cathode that receives the positively charged electrons. It is the cathode that um, that receives the positively charged electrons. So let's proceed and let's not get back to that. So in electrolysis, one of them will be transferred to the electrolyte, to the electrodes, one of the electrodes, and the other will be transferred to the other electrode, because the cathode receives positive electrodes while the anode receives negative electrodes. So what we're trying to determine now is which of the ions is going to be selected, is going to be discharged for electrolysis, for the process. So how do we determine that? There are several factors, and one of them is this. I states that again the ions lower in the electrochemical series will be discharged. So when we look at sodium here and hydrogen here, we look at their ions, we find out and we trace them back to this side. We find out that sodium is higher up in the electrochemical series than hydrogen, and based on the rule that has been set for it, we find that it is the ion that is lower in the electrochemical series that will be selected for the provincial discharge. That might seem funny, so, but that is it. It is the one that is lower in the electrochemical series that will be selected for the provincial discharge, because H is lower, hydrogen ion is lower, while the sodium ion is upper, which indicates that it is what hydrogen ion that will be what selected, that will be selected for it. It is hydrogen ion that will be selected for it. So sorry, few minutes. Okay, back. That's this. So now if we now move to this portion, to this um negatively charged ions, which are which are the anions. We move to the negative charged ions. So when we look at these ions, the negatively charged ions, which are the anions, one of them is also expected to be selected, and which will follow the rule that the ion lower in the activity series will be selected over it. So looking at this here, we have sodium, we have the tetraoxosis acid here at top, and we have the hydrogen oxide here at the bottom. We have hydrogen oxide here at the bottom, which implies that the hydrogen oxide will be selected, which is what is shown here. The ions present are these, OH minus and SO4 2 minus. OH minus will be differentially selected for discharge because of the same reason, because of the position of the ions in the electrochemical series. So now let's move to the second factor that governs the selection of discharged ions, which is the concentration, of the ions, which is the concentration. So let's get that, we'll get to know about it well. So increase in the concentration of an ion affects its discharge. Increase in the concentration of an ion affects its discharge. It affects, rather, the increase in the concentration of an ion affects its discharge, which implies that when the concentration of an ion increases, it also affects its discharge, its ability to leave that portion and be transferred through the terminal, through the electrodes. So increase in the concentration of an ion affects its discharge, e.g. in concentrated HCl, e.g. in concentrated LCl containing OH minus. So now let's write out, because when you are given a question like this, when we are trying to figure out the one that will be selectively discharged, we need to perform an equation like this. So now let's do that now. So in HCl, in concentrated HCl containing this and this, okay, let's do that now. HCl, we have HCl, we also have the water here, and this here decomposes to form nothing less or greater than H plus and Cl minus. Why this decomposes to form, as we all know, as we've written before, H plus and what, OH minus, H plus and OH minus. So now what's the statement here? Increase in the concentration of an ion affects its discharge, right? E.g., in concentration HCl containing OH minus from H2O and what's this? It contains OH minus and Cl minus, and Cl minus, this should be C chlorine ion and Cl minus ions and ions rather. So it's telling us that the anions that will be contained in the electrolysis of hydrogen chloride, the electrolysis of hydrogen chloride, the anion that will be contained with what? So when you ask that question, you are expected to do this so you can get the anion that will be contained. And we know anions are what? The negatively charged ions. Anions are the negatively charged ions, while these are the cations, which are the positively charged ions. So we should be able to do that. So now the anion is telling us that the anions here are these OH minus from H2O and Cl minus ions. So what is it saying? It states that chlorine ion, this should be chlorine ion, preferentially selected for discharge. Chlorine ion is preferentially selected for discharge due to concentration effect. Can you see that now? It states that what? Yeah, we know we may not have to look. Can you see that we may not have to follow this order? The first factor, we may not have to follow the first factor again, because the concentration of the ion also matters. Yeah, well, we find out that chlorine is at the top, while hydrogen hydroxide ion is at the bottom. But based on the rule 1, it is the hydroxide ion that is supposed to be discharged, but that will not happen because of the concentration of the ion. So chlorine is preferentially selected for discharge due to concentration effect. Yes, so what will happen is the chlorine here that will be selected. Okay, it is important to note that it is only in the electrolysis of chlorides that concentration effect overtakes the position in electrochemical series. So let's note that it is important to note that it is only in the electrolysis of chlorides. It is only in the electrolysis of chlorides that concentration effect overtakes the position in electrochemical series, because we find out that the rule number 1 is already disrupted. We can't follow it again. So it tells us that what it is not that you should note that it is only in the electrolysis of chlorides that concentration effect overtakes the position in electrochemical series. So that is it. So now let's proceed. We also have another factor that governs the selection of the ions, which is what? The nature of the electrodes. As we discussed earlier, that electrodes are the two poles that allow electric current to flow in and out. They are the two poles that allow electric current to flow in and out. So they are the electrodes are the two poles again. They are the two poles that allow electric current to flow in and out of the electrolyte. So, and here we have the nature of the electrodes, saying that it also governs the ion that will be discharged. So electrodes may be inert or active. Inert electrodes such as platinum, carbon electrodes, etc. take no part in the electrolytic reaction, but active electrodes take part in the electrolytic reaction, and they influence the ion that will be discharged due to their strong affinity for certain ions. So example here, in the electrolysis of brine, the brine is the solution of is the combination, the mixture of common salt in water, which is brine, the mixture of common salt in water. So in the electrolysis of brine NaCl solution using platinum electrodes, this PT stands for platinum, using platinum electrodes in the electrolysis of brine. So if you write that out here, let's erase this. In the electrolysis of brine, which is, we have sodium chloride here, these are things we should know, and we have water here as well. Okay, this will be what? Na plus the electrolyte, the compounds will decompose to this Cl minus, and this will be what? Okay, we have oxygen here, H plus OH minus. So what does it say? It states that what, in the electrolysis of brine sodium chloride solution, okay, using platinum electrodes, when we use platinum electrodes, H plus is selected. So that shows that when we are making use of platinum electrodes, and you know how electrodes look like, these are the electrodes here. So when we make use of platinum electrodes, okay, sorry, when we make use of platinum electrodes, okay, when you stop, if in the electrolysis of brine using platinum electrodes, okay, using platinum electrodes, what does it state? It says that H plus, which is the hydrogen ion, is selected for discharge in preference to sodium ion. So if we look at the electrochemical series, it states here that what, the hydrogen ion is selected over any sodium ion, hydrogen over sodium ion. Okay, that's, it actually complies with the first rule. So it says that what, sorry, if mercury cathode is used, or where is it here? Okay, in the electrolysis of brine using platinum, you should know that platinum electrodes, the hydrogen ion is selected for discharge in preference to sodium ion. But what if mercury cathode is used? If mercury cathode is used, what will happen? The sodium ion is discharged and it associates with the mercury. What associates with the mercury? The sodium ion that discharges because of the mercury cathode. I told you because of the mercury cathode, I told you the nature of the electrodes also determinant. And if mercury cathode is used, the sodium ion is discharged and it associates with the mercury. What associates with the mercury? Can you see the equation here? The sodium ion associates with the mercury to form sodium amalgam, or it should be to form sodium amalgam. So the Na plus the sodium ion is discharged and it associates with the mercury to form sodium amalgam. So that is it. The nature of the electrodes also determine it. So now we come to the end of today's session, which is the part 1 of our topic of discussion, electrolysis, the Ionic theory. So I'll be giving you some certain questions to solve. You have to attempt this. I must ensure you attempt it and submit the answers to the email address that will be provided in the comment section below. So you must ensure you attempt this. Okay, the next is the part 2 of this session. Okay, thanks for watching.